In this video, I'll show you how to rationalize a denominator. This is part 2. Remember, the whole purpose of rationalizing a denominator is so that we have an expression that does not contain a radical in the denominator position. Starting off with question 1, we have the square root of this quotient. What we can do is distribute this radical to the top part and to the bottom part. Let's do that. A square rooted over the square root of a squared plus b squared. Our goal is to somehow rewrite this expression so that the denominator does not have a radical. So what I'll do is multiply the square root of a squared plus b squared to the top and to the bottom. If you multiply these two denominators together, since they're both square roots, you can combine the radicands. Combining these two, you end up with the square root of a squared plus b squared all squared. Technically, by combining them, you're multiplying them, and since they're both the same, you can write them down as a squared plus b squared to the power of 2. The reason why that's important is because the square root of a squared radicand gets rid of the radical sign, and you end up simply with a squared plus b squared. At the top, however, that's a different story. We're going to multiply this radicand with this a. That gives us a times a squared plus b squared. And at the bottom, we're content with a squared plus b squared because that's the whole purpose of rationalizing. We do not want a radical in the denominator. This is your final answer for question 1. Let's move on to question 2. In question 2, they want us to rationalize 7 over the square root of 4a. To rationalize this expression, we have to inject something in the bottom here so that it becomes a perfect third root. Here's what I mean. To the top and to the bottom, I'll multiply the third root of 2a to the power of 2. And let me explain why I'm doing this. So let me do it at the bottom as well. 2 times a to the power of 2. Just like before, we have two denominators with third roots, so we can combine the radicands. Let's combine 4a times 2 times a to the power of 2. That gives us 8a to the power of 3 underneath the third root. So that's the bottom part. And at the top, we have 7 times this expression. Now watch. What is the third root of 8? It's 2. 2 times 2 times 2 is 8. Let's write down 2. And what is the third root of a to the power of 3? It's a. And at the top, we're left with 7 times the third root of 2a to the power of 2. We've accomplished our goal. We no longer have a radical in the denominator. Let's move on to our last question. We have 2y over 3 times the fifth root of x to the power of 2. Once again, I'll inject at the top the fifth root this time of x to the power of 3 over the fifth root of x to the power of 3. Since we have a fifth root here and a fifth root here, we can combine the radicands, this and this, where we end up with, at the top we have 2y, the fifth root of x to the power of 3. And at the bottom we'll have 3 times the fifth root of x to the power of 5. X to the power of 3 times x to the power of 2 is x to the power of 5. This becomes simply x. And so we're left with the following expression. 3x at the bottom and this expression in the numerator. And so there you have it. 3 examples on how to rationalize a denominator.